the next exercise is about deciding whether a student passes or not an exam. And a student passes the exam if he or she gets a grade higher than or equals to 5. Grades below that, student fails. The grades range from 1 to 10, and we can assume that the system doesn't allow for invalid grades like 0.9 or 10.5. That's good because that's going to reduce the number of tests we do afterwards. So first step, analyzing the variables, their types and ranges. So one input variable is the grade. It's a float number that varies from 1 to 10, and a 1 gets a 0, right? That I can see from this specification. Great. And then the pass, which is an output variable, it's a Boolean, so it means it's a true or false. Dependency among those variables, there are none, right, in terms of input variables, because there's just one input variables, but there is this dependency between the value of the grade and, of course, the pass and fail. Then we can go to the equivalence partitioning and boundary analysis. So first, the two partitions that I see are the 1 to 5 grade and 5 to 10, right? Because that's where we precisely divide students that pass and fail. Look at my notation here. So I'm using this to indicate that it's a closed boundary. So 1 is included and 5, and like this to indicate that 5 is actually out of this partition, right? Great. So these are the two classes that I can see right now. Let's do the boundary analysis. So first, for that side, for the left side of this input range, 1, yeah, so 1 is the on point. The off point would be, for example, 0.9, but it makes no sense for us to test because we know from the requirements that 0.9 is impossible to get into the system. So no need for me to test. And the other on point is 5. And the off point is then 4.9, right? Because 5 makes the student to actually pass. So the boundary there is between 4.9 and then 5. And then for the second class, then the boundaries are 5. So although repeated here, just for the sake of completeness, I'm putting it here. And then 10. And I could also try a off point, 10.1, but well, I know that it's impossible to get it into my system, so I don't need to test. So then at the end, my strategy to generate tests will be just to generate tests for the boundaries because they seem enough to me. So 5 tests for boundaries, 5 test cases. For those here, the output is fail. For those other 3, the output is pass. I said 5, but it's just 4, right? Because 5 is duplicated here, so these are the 4 tests. And then I just decided to add 1 extra in point because I felt like why not testing 1 more. So you see, this is where I want to discuss this trade-off. So maybe testing only the boundaries is enough because, you know, if you think about it, if you're testing on and off points, you're naturally also testing in and out points, right? Because on and off points belong to either in or out points. In very large and complex problems, maybe it's just too much and then you have to prioritize. In here, it's a very small problem. We could try 1 more, right? Maybe in this, actually in a real life problem, maybe because the number of grades is not so big. Let's suppose the system only allows for 1 digit after the decimal point. So 0, 1, 1.1, 1.2, 1.3 up to 10. The number of combinations is not so small, right? Maybe we can write tests for all these combinations in an automated fashion. But in here, I want to focus on the equivalence partitioning analysis, and that's how I would do this if it was impossible for me to test everything, okay?